All right, well, good morning. Monday, March 2nd. I'm sorry I'm not there. I really hoped to be back by today. I guess something came up and I'm not there. But we've got lessons all week again. And next week if I need it as well. I really don't know what's going on or when I'm going to be back, but we should be well prepared. Moving on, in Chapter 6, we looked at some of the basic trig stuff and the special right triangles, that 30, 60, 90, and the 45, 45, 90 triangle become very important. Today we're going to extend the idea of trigonometric functions and start looking at a lot of other applications and getting into something called the unit circle, which might be something that you've seen of, you've heard of before, depending on who you had for your in previous math classes, in your college algebra and algebra 2. Hopefully you've seen a little bit of unit circle stuff. Why is it so important? What's the significance of that? And we're going to talk about it. And there's quite a bit of memorizing. In today's folder, there is a flashcard game, which the idea behind the cards is, and if we could get somebody in the class to play the cards, either the student tutor or the sub, to hold up the cards, and you either have to, if it says a degree in degrees, you have to tell me what it would be in radians, or if you flip it over in radians, what would it be in degrees? I've got whiteboards that you can use with markers and erasers. We can have a little bit of fun with the game, but really getting to know those reference angles and being able to know them cold, degrees to radians, radians to degrees, knowing them back and forth. Today we're going to look at some angles that maybe are not so friendly angles, and how do we deal with the ones that are not so friendly. So, Monday, March 2nd, extending the trigonometric functions, part 1 of today's lesson. All right, here we go. So in part 1, what I want to do is I want to look at any angle, and I'm going to look at an angle on a coordinate graph. So if I've got some sort of coordinate graph and I've got some sort of point here, and I'm going to give myself a point and it's got an x value and a y value. And the point is on the terminal side of my angle. So my angle in standard position is going to look like this. Starting from the horizontal, going counterclockwise, there is my theta. And the x and the y value is just the coordinates. Now notice, depending on what quadrant it is, x's could be positive and y's could be positive or negative, y's could be positive or negative. But I want to take a look at the different trigonometric values of theta. The other thing that I need to know, and if I take a closer look at, well, what does the x and the y really represent? Well, the x-coordinate is really this distance right here. That's my x-coordinate. The y is really this distance right here. That's my y distance. What don't I know is this distance. Well, why is this important? Well, this becomes the base of my right triangle, another base of my right triangle, the two legs, and that's the hypotenuse. I'm going to call that r for radius right now. R for radius. And as you can guess, later we're going to deal with the special case where the radius is always going to be 1. And if the radius is 1, then I get a unit circle, and I get all of my special identities here. So if I want to take a look at my theta, and I ask myself, well, what's the sine of the angle, the sine of the theta? Sine of theta is opposite over the hypotenuse. The opposite is the this value here, not x. This would be the y value over the r value. What's the cosine? Would be the adjacent over hypotenuse, x over r. What's the tangent of my theta? The tangent opposite over adjacent would be y over x. Oh, and look, I've got a restriction. Well, I had restrictions here too. My radius cannot be 0. My x cannot be 0 here. Bad things would happen if it's 0. What about the cotangent? Well, remember the trick? If you know sine, cosine, and tangent, you know cotangent, secant, and cosecant. Those are the reciprocals. Cotangent is 1 over tangent, so it would be x over the y value. Secant is 1 over cosine, so it would be r over x. And cosecant is 1 over sine, which would be r over y. So this is just a very general idea here about what the ratios would be, the trigonometric ratios of an angle given some point on the coordinate plane, some x and y value. These are how I would calculate all the different values, the 6 trigonometric values. Let's get specific. Let's pick a point and do this, and let's be very specific about a point. So, in my next example, we're going to pick coordinates. I'm going to create, and I'm going to pick some point over here, and let's call it, let's call the coordinates here -6, 3. So this is -6, and this is 3. My angle in standard position, there it is. My x and my y values, very important. This value is 6, -6. This value is +3. And I want to know what are the sine, cosine, tangent, cotangent, secant, and cosecant, 1, 2, 3, 4, 5, 6, of all of them. And remember, if I know sine, cosine, and tangent, then I know those. Those are just the reciprocals. What thing am I missing, though? What do I need to know? Well, I don't know my radius. I need to know the r value here. What is the radius? What is that r value? How am I going to find that? Well, Pythagorean Theorem. A squared plus b squared equals c squared. -6 squared plus 3 squared is c squared. 36 plus 9 is c squared. 36 and 9 is 45 equals c squared. The square root of 45 is c. Does square root of 45 have a nice, well-behaved number? No, but it's 9 times 5. So can I rewrite that as 3 times 5? 3 root 5 is my c value. 9 times 5 is 45. 3 root 5. Yeah, that seems right to me. Okay, so now, what is my sine? My sine is going to be the y value, which is 3 over 3 root 5. Notice the 3's are going to cancel. 1 over root 5, rationalize the denominator, root 5 over 5. And of course, if I know this, I know cosecant is just going to be root 5. How about the cosine? Well, the cosine is the x value over the r value, -6 over 3 root 5. The -6 and the 3 I can simplify. I'm going to get -2 over root 5. Rationalize the denominator, -2 root 5 over 5. And of course, if I know this, I know the secant here is going to be -5 over root root 5 over 2. Root 5, oh, I messed that up. Let me redo that again. So that's going to be, flip it, it's going to be root 5 over 2 negative. Right, negative here. Well, what's the tangent? The tangent is the y value over the x value. The y value is 3 over the x value of -6, -1/2. Flip it, and I get -2. So, the sine, cosine, tangent, cotangent, secant, and cosecant. Notice some of them are positive and some of them are negative. And we should be able to tell which ones are positive and which ones are negative just by what quadrant it's in. Let's take a closer look at that and explore the quadrant. So what I'd like to do now is I'd like to draw a nice diagram of my 4-quadrant graph. Notice I'm drawing it kind of big here. I'm going to put a lot of information in here. So draw it so it's a good like half of the size of your paper. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. Now, what do I know about each of the quadrants? Well, the first, I know that the angles here are between 0 pi and pi over 2 in radians, or 0 degrees and 90 degrees. In quadrant 2, they're between pi over 2 radians and pi, or in degrees, between 90 degrees and 180 degrees. In quadrant 3, I know that they're between pi and 3 pi over 2, which is the same thing as 180 degrees and 270 degrees. And in quadrant 4, they're between 3 pi over 2 and 2 pi, or 270 degrees and 360 degrees. So my angles, just where the angles are, what are the angles in there? I know that in quadrant 1, my x values are positive and my y values are positive. In quadrant number 2, my x values are negative. My y values, however, are positive. In quadrant 3, my x values are negative. My y values are also negative. And in quadrant 4, my x values go back to being positive and my y values are still negative. So when I look at these and I say, okay, so now what trigonometric functions are positive and negative and very, very important concept here, positives and negatives. Well, if the x's and y's are positive, then I know that my sine is going to be positive, my cosine is going to be positive, and my tangent is going to be positive. However, over here in this quadrant, I know that my sine is my y value, sine is going to be positive, but my cosine is going to be negative, and my tangent is, sine over cosine is going to be negative. Here, x values are negative, y values are positive. My sine is going to be negative. My cosine is going to be negative, but a negative over negative is a positive. My tangent is going to be positive. Over here in quadrant number 4, my sine and my y values are going to be negative. My cosine, my x values are going to be positive, and a positive over negative, my tangent is going to be negative. Now notice I didn't put down cotangent, secant, and cosecant because they're going to have the same signs. If tangent's positive, cotangent's positive. If tangent's negative here, cotangent's going to be negative. If tangent's positive here, cotangent will be positive. And if tangent is negative here, cotangent will be negative. There's a little acronym that we sometimes use to help us kind of memorize this, and we can think about it if we just remember that all students take calculus. All students take calculus. All all of my things are positive here, all of them. Sine, cosine, tangent, and therefore cotangent, secant, and cosecant. Sine is positive here. Cosine and tangent are negative. Therefore, cotangent and secant are negative, and cosecant would also be positive. Tangent is positive here. Therefore, cotangent would be positive. Sine and cosine are negative. Therefore, cosecant and secant would also be negative. And cosine is positive here. Therefore, secant would be positive. Sine and cosecant, tangent and cotangent would also be negative here as well. All right, so good thing to look at, to think about. Kind of let's put this to the test now. And I'd like to give you some angles. And all I want you to do, we're going to test some angles here. And I want you to tell me, would these be positive or negative? So I want to find the sine, S-I-G-N, of the trigonometric function. So I'm going to give you an angle. Let's start with something like 150 degrees. And if I want to think about 150 degrees, I want to know which trigonometric functions are positive, which ones are going to be negative. Well, what quadrant? It's all about what quadrant. What quadrant is 150 degrees in? 150 degrees is in the second quadrant. So the sine is going to be positive. The cosine is going to be negative. The tangent is going to be negative. And therefore cotangent's negative, secant's negative, and cosecant would be positive. All right. How about angle 5 pi over 4? All right. So again, I have to think about, okay, what angle, what quadrant is 5 pi over 4 in? 5 pi over 4 is a little bit more than 4 pi over 4. 4 pi over 4 would be pi. That's 180 degrees. So this is definitely going to be in the third quadrant. So in my third quadrant, I know that the sine is going to be negative. The cosine is going to be negative. And the tangent, negative over negative, would be a positive. So what is the sine of 5 pi over 4? I don't know right now, but I know it's a negative number. What's the cosine? I know it's going to be negative. What's the tangent? I know it's going to be positive. All right, one more. How about the angle negative pi over 4? Negative pi over 4. Okay, let's see. What quadrant is negative pi over 4 in? Negative pi over 4 is going to be in the fourth quadrant. So in the fourth quadrant, I know that my sine is going to be negative. So the sine of that is going to be a negative number. I know that my cosine, however, will be positive. So the cosine of that would be a positive number. And I know that my tangent down there in the fourth quadrant would be negative. So the tangent of that would be a negative number there. All right, this is usually where I would ask to see if there's any questions or anything like that, but kind of moving on here, let's take a look at the next idea, the next concept. Let's take a closer look now at what happens if I have, and here's where we start talking about some of our special. What about if I have an angle, some point, some x and y, but now the distance is 1. It's 1 unit away. So I've still got my x value and my y value, but now my radius, my distance from the origin of my angle, remember here's the angle, in standard position, there's my theta, the radius is going to be 1. So now, what is the sine? What are the trigonometric functions here? What's going to be the sine of the angle, the cosine, the tangent, the cotangent, the secant, and the cosecant? Well, sine, I know, is the y value over the r value, but my r value is 1 now. So the sine is really just going to be the y value. My cosine is the x value over the r value, but my r value is 1. So it's really just going to be the x value. My tangent is going to be the y over the x value, which is just going to be y over x. Cotangent is going to be x over y, which is just x over y. I can't do anything with that. The secant, think about it as the inverse, is going to be r over x, but my radius is 1, so 1 over x. My cosecant, r over y, but my radius is 1, so 1 over y. So this is where we start talking about the importance of having the radius of 1 and dealing with a radius of just 1. All right, so at this point, what I'd like to do is, if you haven't already done it, hand out the unit circle worksheet, and we're going to start taking a look at that unit circle worksheet, and we're going to start plugging numbers in and start playing around with that the unit circle worksheet. So we'll continue again here in a moment. Take it out, take a look at it, look at the little triangles at the top. Actually, maybe start by filling in those little triangles. And as we take a look at the little triangles, I want you to think about them as being ones. So if I have 30, 45, and 60, but now I want all of the distances, these are my angles, this is my distances, I want all of the distances to be 1. So if all of the distances are 1, what would the other distances be here? So hand out the unit circle, see if you can figure that out. Remember 30, 60, 90, we're used to having it as 1 and 2 and root 3. 45, 45, 90, we're used to having it as 1 and root 2. Or x and root 2. Here we're used to having this as 1 and 2 and root 3, but solve for these sides and get them so that they all have the radius of 1. And I'll be right back.